On any given day, more than 87,000 flights are in the skies in the United States. To handle all of this traffic, the FAA has developed what is called the National Airspace System. The atmosphere is divided up into unique sectors, with each sector's properties based upon that area's level of traffic and any particular needs of that area. The National Airspace System divides up the classifications of airspace based on the level of air traffic, the nature of the operations conducted, the level of safety required, and national and public interest. Busy airports, like Chicago's O'Hare, will be classified differently from a single runway airport in the middle of nowhere. Areas like the Kennedy Space Center and Washington, D.C. have unique rules which restrict or prohibit aircraft from flying in that area due to safety and/or security reasons. There are two categories of airspace or airspace areas: regulatory and non-regulatory. Regulatory airspace has a set of specific regulations that govern that area, whereas non-regulatory airspace is just used to advise or warn pilots of the operations that are conducted within the airspace. Regulatory airspace consists of classes A, B, C, D, E, and G, restricted areas, and prohibited areas. Non-regulatory airspace consists of military operation areas, or MOAs, warning areas, alert areas, and controlled firing areas. Within these two categories, there are four types: controlled, uncontrolled, special use, and other airspace. Each unique sector of airspace is defined by its lateral and vertical boundaries. The lateral boundaries can be thought of as the airspace's footprint along the ground. It can range from as simple as a circle surrounding an airport to a complicated, multi-sided polygon. The vertical boundaries describe the upper and lower altitude limits. These altitudes are labeled in one of three ways: AGL, or above ground level, which describes the altitude in terms of height above the ground; MSL, or mean sea level, which describes the altitude in terms of height above the average sea level. And this is the altitude that is read off an aircraft's altimeter. Finally, flight levels, which also describe the altitude in terms of height above the average sea level, but is also based upon using a standard pressure of 29.92 inches of mercury. Flight levels are typically used to measure an aircraft's altitude when at 18,000 feet MSL and above. This would then be labeled as Flight Level 180. To figure out which classification of airspace you are navigating through, there are various aeronautical maps, called charts, which can be used. The most prominent chart beginning pilots will use is the sectional chart. Sectional charts provide detailed information to aviators, such as terrain elevation, ground features, airports, and other information, including airspace classes, navigation aids, radio frequencies, and navigation routes. One other factor to remember when dealing with airspace is the difference between IFR and VFR flight plans. IFR stands for Instrument Flight Rules, meaning that the flight occurs using the aircraft instruments as the primary reference, instead of VFR, or Visual Flight Rules, where the pilot uses outside references like the horizon and landmarks on the ground to navigate. Each of the different types of airspace has specific requirements that must be met in order to operate in it. These include, but are not limited to, pilot qualification requirements, aircraft equipment requirements, cloud clearance and visibility requirements, speed requirements, etc. An easy way to remember Class A or Alpha airspace is that it is above the airspace that small aircraft operate in. Most of the traffic operating in Class A airspace will be commercial airlines or corporate and military jets. Class A airspace is located from 18,000 feet MSL up to and including flight level 600 and covers both the 48 contiguous states and Alaska and extends offshore 12 nautical miles. Aircraft that operate in Class A airspace must be on an instrument flight plan, be in an instrument-rated airplane, and be flown by a pilot with an instrument rating. While operating in Class A airspace, two-way radio communication with ATC must be maintained. The aircraft must possess at least a Mode C transponder, and if operating above 24,000 feet MSL, must also possess some form of distance measuring equipment like GPS. A transponder is a piece of equipment that helps relay the location and speed of an aircraft to an ATC radar station. Transponders equipped with Mode C also relay the aircraft's altitude to ATC. Because all operations are conducted in accordance with instrument flight rules, there are no specific weather requirements. There is no speed limit other than to remain slower than the speed of sound. Finally, when operating in Class A or any time above 18,000 feet MSL, make sure to reset the altimeter setting to 2 Class B or Bravo airspace surrounds the nation's busiest and largest airports. To find Class Bravo airspace on a VFR sectional chart, look for the solid blue lines. The lateral distances of the airspace will vary with the local area, but will typically maintain the shape of an upside-down wedding cake with several layers. Vertically, this airspace is generally located between the surface and 10,000 feet MSL, but exceptions do exist. Inside each unique sector of airspace, there are numbers published on sectional charts to indicate the vertical dimensions of Class B airspace in that sector. In this example, at Orlando, Florida, the top of Class B airspace is located at 10,000 feet MSL, and the bottom is located at 6,000 feet MSL. In order to operate in Class B airspace, there are several requirements that must be met. The pilot must be at least a private pilot, or a student pilot with the necessary endorsements. Two-way communication with ATC must be maintained, and in addition, a clearance to enter the airspace must be given to the pilot.
Kayak 454 Echo Romeo, clear to enter Orlando Bravo airspace.
And the aircraft must possess a Mode C transponder. There are 12 airports around the country that student pilots are never authorized to enter, even with an endorsement. These are the busiest of the busy airports, and therefore cannot handle student pilots. A listing of these airports can be found in the Aeronautical Information Manual, or AIM, in Section 3-2-3. A 30-mile ring, known as a Mode C veil, surrounds the primary airport of Class B airspace. An aircraft must operate with a Mode C transponder within this ring, even if they are not necessarily inside of Class B airspace. This is shown on a sectional chart with a solid magenta line and the label 30 nautical mile Mode C. The minimum weather requirements for Class B are as follows. The visibility must not be any less than 3 statute miles, and the pilot must remain clear of any clouds. Speed limitations in Class B airspace are twofold. When operating below 10,000 feet MSL, the speed limit is 250 knots. Whenever operating below Class B airspace, the speed limit is 200 knots. Class C, or Charlie airspace, is designated for airports like Daytona Beach International Airport that are not as busy as Class B, but are still busy enough to require radar approach assistance to organize and separate aircraft traveling into and out of the local area. This airspace is labeled on a VFR sectional chart using solid magenta lines. The typical shape of Class C airspace contains 2 cylinders, the inner core and the outer shelf, but can be tailored to meet the needs of certain airports. The core consists of a 5 nautical mile area extending from the surface up to 4,000 feet AGL. The shelf consists of a 10 nautical mile area that extends from 1,200 feet AGL to 4,000 feet AGL. These altitudes are labeled in reference to MSL on aeronautical charts. Radar coverage is available up to 20 nautical miles from the airport. Some Class C airports, like Orlando Sanford, lie underneath Class Bravo. Airspace like this may have custom dimensions that extend up to the floor of the Class Bravo. The requirements to operate in Class C are as follows. Pilots must be rated at least a student pilot. Aircraft must possess a Mode C transponder. No clearance is necessary to enter, but two-way radio communication with ATC must be established and maintained. If the controller responds to your initial call with your call sign, you are cleared to enter the airspace. The one exception would be if they replied to your call with the phrase, "Remain clear of Class Charlie."
Skyhawk 454 Echo Romeo, remain clear of Class Charlie.
To operate inside Class C VFR, the visibility must not be less than 3 statute miles, and the pilot cannot be any closer to the clouds than 500 feet below 1,000 feet above, and 2,000 feet horizontally. As previously stated in Class Bravo, anytime the aircraft is operating below 10,000 feet, the speed limit is 250 knots. That limit is reduced down to 200 knots when operating below 2,500 feet AGL and within 4 nautical miles of the primary Class C airport. Class D, or Delta airspace, is controlled airspace surrounding smaller, local airports that are quiet enough to not require any radar separation, but still busy enough to require a control tower. This airspace is labeled on a VFR sectional chart using dashed blue lines. The dimensions of Class D airspace are relatively simple, consisting of a single cylindrical area, generally extending from the surface up to 2,500 feet AGL. Just as stated for Class C, the altitudes shown on VFR sectionals are labeled in MSL. Similar to Class C, occasionally a Class D airport may be located underneath either Class B or C airspace. In these cases, Class D will extend up to the floor of the underlying airspace. Ormond Beach and New Smyrna Beach airports are located underneath Daytona Beach's outer shelf. Since the Daytona shelf begins at 1,200 feet MSL, Ormond and New Smyrna extend up to, but not including, 1,200 feet MSL. The typical radius of the airspace is about 5 nautical miles, but can vary between 3 and 7 nautical miles. To operate in Class D, the pilot must be at least a student pilot, and two-way radio communications must be established with the tower. Flying VFR in Class D requires the visibility to be at least 3 statute miles, and to get no closer to the clouds than 500 feet below, 1,000 feet above, and 2,000 feet horizontally. As previously stated, the maximum speed one can operate below 10,000 feet MSL is 250 knots. However, when at or below 2,500 feet AGL and within 4 nautical miles of the Class D airport, the maximum allowable speed is only 200 knots. Class E, or Echo airspace, is defined as controlled airspace that is not Class A, B, C, or D, and is one of the largest parts of the National Airspace System. Since this may seem like a vague definition, we can split the airspace up into 7 unique types or locations. To remember them all, we'll use the acronym SETFOOD. Surface area designated for an airport. This area is depicted surrounding an airport, starting at the surface much like a Class D airport, and is designated to be configured to contain any instrument procedures for that particular airport. It is depicted on a VFR sectional chart with a dashed magenta line. Extension to a surface area. These areas serve as extensions to Class B, C, or D to allow for instrument approach procedures into that airport. This area is also depicted with a dashed magenta line, but does not surround an airport. Airspace used for transition. These areas are used to transition aircraft to or from the terminal area and en route environments. A vignette is used to depict these on sectional charts. A magenta vignette indicates the floor of the Class E at 700 feet AGL, and a blue vignette indicates the floor at 1,200 feet AGL. Federal Airways. These airways can be thought of as the highways in the sky and serve as a popular method to get aircraft to their destination. Each airway is 8 nautical miles wide and starts at 1,200 feet AGL, extending up to but not including 18,000 feet MSL. Offshore airspace areas. This airspace is used to allow ATC to provide services to IFR traffic that operate beyond 12 nautical miles from the coast. The borders of these areas depicted on a sectional chart resemble that of a zipper. The floor of each sector is indicated inside each respective area. Other. In certain parts of the country, Class Echo does not start until 14,500 feet MSL, excluding any areas that are within 1,500 feet of the ground. This airspace continues upward until reaching 18,000 feet, which is where the Class Alpha starts. At flight level 600, where Class Alpha ends, Class Echo continues upward to an indefinite altitude. En route domestic areas. These areas are located outside of any federal airway to allow for ATC to separate traffic. This example shows an area of echo airspace between two airways beginning at 12,000 feet MSL. There are no defined vertical limits to Class Echo. This airspace will either start at the surface or a defined altitude and continue upward until coming in contact with a different class of controlled airspace. There are no specific pilot qualifications, equipment requirements, or operational procedures necessary in order to fly within this airspace. Because Class Echo can be located in many different areas, the weather minimums to operate VFR within Class Echo depend on your altitude. When below 10,000 feet MSL, the visibility must be at least 3 statute miles, and pilots cannot be any closer to clouds than 500 feet below, 1,000 feet above, and 2,000 feet horizontally. However, when operating at or above 10,000 feet MSL, the requirements increase. There, the visibility must be at least 5 statute miles, and aircraft must remain at least 1,000 feet below, 1,000 feet above, and 1 statute mile horizontally from any clouds. Similar to other airspace, the maximum airspeed an aircraft can fly is 250 knots when below 10,000 feet MSL. There is no speed limit when at or above 10,000 feet, except to remain slower than the speed of sound. Class G or Gulf airspace is uncontrolled and makes up the rest of the area that has not been designated already as Class A, B, C, D, or E. This airspace starts on the ground and continues upward until coming in contact with another class of airspace, usually Echo. In the majority of the country, this would mean that Class Gulf would extend up to, but not including, 1,200 feet AGL. The highest altitude Gulf will ever go up to is 14,500 feet MSL, unless within 1,500 feet of a really tall mountain. Just like Class Echo, there are no specific pilot qualifications, equipment requirements, or operational procedures necessary in order to fly within this airspace. The weather minimums to operate VFR in Class Gulf are relatively complicated and depend on both the aircraft's altitude and time of day. To organize all the various possibilities, let's create a chart. Anytime the aircraft is within 1,200 feet of the surface, regardless of the MSL altitude during the day, the aircraft is required to remain clear of clouds, and the visibility must be at least 1 statute mile. At night, the visibility must be at least 3 statute miles, and cloud clearances are 500 feet below, 1,000 feet above, and 2,000 feet horizontally. When flying above 1,200 feet AGL, but less than 10,000 feet MSL during the day, the minimum visibility is 1 statute mile, and again, 500 feet below, 1,000 feet above, and 2,000 feet horizontally from clouds. At night, the visibility is once again 3 statute miles, and the same 5, 1, and 2 for cloud clearances. When flying both above 1,200 feet AGL and 10,000 feet MSL, regardless of the time of day, the visibility must be at least 5 statute miles, and the cloud clearances are at least 1,000 feet below, 1,000 feet above, and 1 statute mile horizontally. This is the same requirement for Class Echo above 10,000 feet MSL. As previously stated, the maximum speed an aircraft can fly is 250 knots when below 10,000 feet MSL. There is no speed limit when at or above 10,000 feet, except to remain slower than the speed of sound. You might have noticed there was no listing for Class F or Foxtrot airspace. This is because in the United States, the FAA National Airspace System has not declared any airspace that falls under this classification. However, in other countries around the world, Class F airspace does exist.